the Stanford report, they've done a Stanford report on redwood recycling. It's still under peer review, but found that redwood's recycling and refining operations cut carbon dioxide emissions by 70% compared with traditional recycling methods. So they've got they're not just recycling, they're doing it, with lower carbon emissions, significantly lower than other people who are doing it. They're coming up with a way to do it right. 70% compared with traditional recycling methods and 40% lower than other recycling processes. More than 95% of the key minerals can be profitably recycled. More than 95%. So nothing goes to a landfill at this facility, and no water leaves the facility except the sanitary waste from sinks and toilets. There's no gas lines, Brian. Everything is electric. So if everything is electric, you can power it with clean, renewable electricity if you want. And that is what they are aiming to do. So a quote here from Colin Campbell, their Chief Technology Officer, says, once we've changed over the entire vehicle fleet to electric and all those materials or all those minerals are in consumption, we'll only have to replace a couple percent each year that's lost in the process. There are 3 basic approaches to recycling batteries, each with its own drawbacks. You can burn them, which is wasteful and can result in toxic emissions. You can dissolve them in strong chemicals, which is expensive and uses the most energy, or separate them mechanically, which can be labor-intensive and dangerous. Until the last few years, most U.S. recyclers simply ground up the batteries and sent them overseas for someone else to deal with. But Redwood Materials is borrowing what it sees as the most useful bits from each of those categories of recycling. The company's process starts in an indoor staging area where everything from discarded earbuds that have batteries in them, Bluetooth headphones, laptop batteries, EV modules from recycled Chevy Bolts are dumped because there was a big Chevy Bolt recall. The battery has a defect in them from LG. And they're dumped into a conveyor belt, and the jumbled mess is carried roughly 30 feet up to a hole in the wall where it exits the building into a giant churning metal tunnel dubbed RCI, suspended high above the ground. RCI is essentially an enormous slow cooker, baking the junk at several hundred degrees for about an hour, and is perhaps Redwood's biggest innovation thus far. Traditional recycling through burning uses heat well over 1,000 degrees Celsius or 1,800 Fahrenheit to separate out precious metals, but Redwood's goal at this stage is to preserve and prepare the materials for the next steps in the most efficient way. So they're only doing it at a lot less temperature. There's no combustion involved here. Like I said, it's electric heating and no emissions. No combustion, no emissions, which is actually surprising to me. I thought there would be a more of a hurtful carbon process, but it's actually a lot better than I ever hoped for. It simply reduces the glues, plastics, and unwanted fluids into charcoal. The high-grade black carbon, weren't we just talking about that? Leftover can be sold for use in black paints and industrial lubrication, possibly wetsuits. I don't know.
Yeah, probably, yeah.
So it uses surprisingly little electricity. Once the kiln heats up, the energy released from the batteries is self-sustaining because it starts to have a chemical process and give off the energy that it had stored. Think of it as a controlled slow-motion version of a battery fire running non-stop day and night. Week after week, it safely releases the charge in any batteries that could pose a danger to workers while breaking down the stuff that binds key minerals together. That's ingenious, if you ask me. It's using their own heat that's already there, the battery's potential. After leaving the RC, is it RC1 or it's the RC1? Okay, I said RCI. The charbroiled batteries pass through machines that sift the material through screens. Powerful magnets are used to isolate certain materials. The remaining mineral-rich dust, known as black mass, is mixed into a slurry of solvents and fed into another building that resembles a large beer brewery with towering stainless steel tanks that uses chemicals, pressures, and filters and evaporation to separate the products into their core elements. So you got your lithium, you got your copper, you've got some cobalt in the older batteries, and all these things are getting separated. And copper foil production has never existed in the United States. For the last year, Redwood has been cranking out sample rolls of copper foils for batteries for them to test. In the coming weeks, the company's foils will officially enter the supply chain used in American EVs. Fantastic. So now when you buy an EV, you're going to have some of it that's already recycled. The CEO of the company chalks up the accelerated timetable to unanticipated EV recalls, like the Bolt, and higher than anticipated levels of scrap materials from new battery factories. Apparently, battery factories, like cookie factories, have some mistakes, because I went and ate some of the mistakes at the Peak Fiends factory in Toronto, which you sent me to. So I've got 10 pounds of fat here. That's all on you, Brian. And yeah, so they make mistakes, and that stuff, is not good enough and has to be recycled. But it's great that it can be.
No, and I've often wondered about things like earbuds, like the ones that I'm wearing right now that have tiny little batteries in them. But I guess it's possible.
Yeah, I wonder about that too. So it's exciting stuff, and I'm really glad to see it happening.